Starch is an incredibly important and incredibly abundant biopolymer all around the world, whether it's tapioca or potato starch in various forms. It's important for nutrition. For example, with French fries. We found it is also a very important reinforcing agent in silicone elastomers. The first example is shown here, where we take a byproduct of one of the undergraduate experiments that we do. That's the reaction of cyclopentadiene and maleic anhydride, a Diels-Alder reaction, to give this anhydride that somewhat surprisingly undergoes hydrosilylation reactions, surprisingly because it's an internal double bond, to give this disiloxane with an anhydride on each end. Now you can do acid catalyzed equilibration and change the molecular weight to whatever you want, again, to give this telohelic anhydride, which upon heating with a bit of base and DMSO and starch leads to elastomeric materials. You can control the cross-link density and therefore control how elastic they are. And you can incorporate up to 70 weight% of starch in this material. The surfaces are initially hydrophobic, high contact angles, but gradually water is absorbed, and you see this through changes in the opacity of the system. An alternative strategy is the Pierce-Rubinstein reaction, where silicon hydrogen bonds will react with OH bonds, including alcohol bonds, to initially lead to the formation of siloxanes or alkoxysilanes, really. These also can form products with starch, but no longer elastomers, they're foams, because the hydrogen that's generated during that process is also a blowing agent. These pictures show samples of the same amount, 50% by weight, of starch in the silicone foam, and the changes here in the amount of foaming just as the amount of silicon hydrogen that we put in there. Some of these actually are pretty brittle, as you can see here. The work is contained in this paper, Open Access and Sustainability, talking about how starch helps improve the sustainability of these silicones by diluting out the silicone and yet delivering interesting properties. Thanks for your listening.